Okay, so Sue's bike had a problem where it wouldn't start and it was going click, click and flat. So the battery I pulled out and put it on charge for 24 hours. It charged up, and then over the next few hours it reduced voltage, so it was rubbish. And just to make sure, we did a crank test on it, and it cranked all the way down to 7 volts, so it shouldn't go lower than 10 volts. So I got rid of that, went and got a new battery. New battery was fitted, but the problem you've got with the Heritage is you can't get to the battery to jump start it if you need to jump start it. So what I've done is I've brought a pin up from the battery, as you can see there, with a plastic mounting piece and a pin with a lead going straight to the positive terminal of the battery. So if we ever need to jump it, it's just a matter of going on the frame somewhere and going on that. So all you got to do now is remove the seat to be able to jump start the bike. Now once the new battery was in, I've tested the charging voltage, and the charging voltage is sitting at 15.5, so that's way too high. What cooked the old battery was obviously the regulator. The regulator sits down here, and I'd say Sue needs a new regulator. That's the next step. So nice new regulator fitted, a rectifier regulator, and now the voltage is sitting correctly at 14.3. If you don't know how the charging system works on the Harley, it's pretty simple. In there, behind the compensator, is a drum with magnets on, which is attached to the end of the crank. And then in that drum goes a bunch of windings. As the drum spins and the windings don't, the windings create electricity through magnets cutting through wire, and it creates a current, right? So an AC power supply. Now the AC power supply varies from at idle about 21 volts to AC, revving up to 70 volts AC. Now in the later models, like the 18s, they are a star configuration. There's 1, 2, 3 sets of windings, because it's a 3-phase star configuration. Then is it gives you one sine wave on one phase, one sine wave next to it on the next phase, and one sine wave next to it on the next phase. And what that does, that gives you an AC current, which basically sits up here between your 21 and 70 volts. Now from there it goes to the rectifier. Now the rectifier rectifies the AC to DC, and how it does that is it has some diodes which only pass the positive part of the sine wave and not the negative part of the sine wave. And after it goes through the 4 diode circuit, it basically clips the top. So instead of having a sine wave that goes over and under the 0 point, now it'll have a sine wave that goes up, 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 up above the 0 point. Therefore at those peaks, if you drew a line across that, respect to 0, that line on the peaks where the peaks meet would be your new DC level line. Now that can be up to 20 volts basically, DC and higher. And then from there, the regulator part simply cuts the amount of voltage to your recommended value of voltage for charging the battery, which is somewhere between 13.5 to 14.5 volts basically. You would think it just reduces the voltage, but what it does is it actually has a thyristor in. It turns that on and off so that it reduces the amount of voltage coming through to the rectifier, and it does it like multiple times a second, so that in the end you won't see it at all, but it's a steady state of value down to the correct value of regulation to your battery charge requirements. Here's some information on the AC and DC signals. Now most vehicles are 13.5 to 14.5, which is pretty standard across the board. Anything lower than that, you're not getting enough charge to your battery. Anything higher than that, you're giving too much charge to your battery, so you can have computers shutting down, you can have lights brightening and dimming, you can have even effect where you'll basically burn out the battery because you're supplying too much voltage to it. The funny thing is, the service manual for the electrical system for the Heritage here, it says the charging voltage should be between 13.5 and 15. So 15 is your maximum voltage it should be putting out, and 14.5 is ideal. The issue that we might encounter is the computer warning only goes off at 16 volts. You could quite happily have a dud regulator like Sue had. It would not give a warning on the dash to say that it was dud because Sue's was only sitting at 15.9. What leads you to believe there's a problem with the regulator is your battery going dead because it's going to kill the battery if it's such a high voltage, which is pretty well what happened to Sue. From an electrical viewpoint, to understand if you're having a charging problem, just check your charge voltage, and if your voltage is low or you're not getting enough voltage, that's likely coming from your stator, which sits in behind here. One of those three-phase windings shorted, obviously you're only going to get two-phase, you're going to get a reduced amount out. If you've got a bad connection or total bad stuffed up stator because it's gone on kilt and it's hit the drum and smashed it to bits basically, you're going to have a low amount of current, and you'll know that by obviously the battery going flat. You might start your bike and you jump start it and you get it from one place to the other, but on the way it stops and stalls. It won't continue to run itself. That's how you can tell if it's a low voltage. It's generally the stator problem. If it's a high voltage, it's generally the regulator problem. So with a high voltage, you've got to know by, like I said, in that level, if it's just a little high, like Sue's was, like one volt higher, but not enough to trigger the alarm, you won't get a code. But what you will get is a dud battery, because it will burn the battery out, or you might get some flickering lights or flickering gauges. There is situations where you'll also have a bad regulator with a low voltage, but it's pretty easy to check. There's three phases, so there's 3 pins on the back of the regulator which check the stator. So you can put a meter on the back of the regulator wiring and check the stator, and you should be getting, like I said, 20 to 70 volts on each phase. And then you can check for shorts by doing the ohms test between the 3 pins, or the three sockets for the stator, and that's not running. And the ohms test will check that you got to check there's no connection between any of the 3 phases, because that'll be a short, or no connection to ground from any of the 3 phases, because that will also be a short. If you're having a charging problem, the first thing you can do is you can measure your stator output as AC on the back of the wiring on the regulator, and if your AC voltages are correct on all 3 phases, then you can pretty well measure the output of the regulator, and if the output of the regulator is high or low, then you'll know it's stuffed. Obviously the basic issues, your battery can be stuffed, or a more complex issue, if it's not the stator or the regulator, is wiring issues and bad earthing issues. So if you got any of those issues, there's checks you can do where you can just check continuity with your ohm setting on your meter between the stator and earth, like I said already, but also the regulator and earth. So the wiring on the back of the regulator to the negative of the earth negative of the bike and the chassis of the bike. So you'll be able to find any earth problems that way, or wiring problems that way. Or a high insulation of your wiring between your regulator and your battery will also cause a high voltage at charge. Pretty simple to find. If your regulator's fine and your stator is fine, you know you've got a problem with your wiring. Anyways, like I said at the start, new battery, new regulator, Sue's bike's up and running. Just a little bit of knowledge and you can pretty well diagnose electrical issues on the bike. It helps if you can research your electrical system manuals or your service manuals for other bits and pieces, obviously. So success, her bike's now running within spec and she'll be happy. I hope this helps someone. You may be able to save a few bucks by doing a bit of work yourself. Cheers.
Remember to like, share, comment and subscribe.
It's free.